Swayam Prabha. Digital India. Educated India.
Welcome back to all my students. This is the 7th lecture, which is the second lecture for the second week. So, as I was discussing, the risk concept and its implication for a project management perspective is very important to understand. And when you are trying to basically understand the concept of risk, to just briefly go through the last slide of the last class, it has basically what are the concept of risk, how risk consequence can be basically mapped or understood considering different type of probability distributions, and how the risk mitigation can be done, and how the documentation and the learning process can be utilized. So, if we come to this slide just after my last class, is basically means the risk impact matrix for project management concept. So, you will basically have the consequence and the likelihood of how the project is being implemented. Now, if you look at the matrix on the y axis, which is this part which I have here, is basically the likelihood, and on the top portion which is so called x axis with the consequences, and there are 9 differentials, not 6, sorry, which basically are the combinations of high and low to high and high, and to the bottom one being low and low and to low and high. So, I will request my students to pause here for a 1 minute. Now, let us go into the concept of probability. So, I am sure people would have learned probability, the concept of inference techniques, and which leads into the concept of hypothesis testing. So, in hypothesis testing what we have basically an hypothesis is there, which is basically the suggested one H naught, and based on that we have an alternate hypothesis which we try to check against H naught, which is known as HA. Now, when you are doing the concept of H naught and HA, if you remember, people who have studied probability and statistics, there are 2 different errors. So, the errors are, if you remember, the chart looks like not exactly like the matrix here, but it looks like this, where if we have an error, I am not going to mark the top row and the leftmost column. What I am interested to note is basically the values of alpha and beta, which are the risk of type 1 and type 2. So, generally we know as type 1 risk and type 2 risk on alpha and beta. So, if you look at an example, now this example which I am going to give may not be very much directly relevant to project management work as such, but it will give you a good idea that how the concept of probabilities and hypothesis testing can be utilized. Consider the example that the project as such is trying to give a loan to different set of people who have applied for a loan in a bank. So, it can be given as an example for a good financial decision making process, can be given as an example for a good concept of how probabilities can be used for a project. So, consider the bank manager has with him or her the set of papers which have been given by each and every person who is applying for a loan. So, those set of papers have been supplied by the bank manager to different individuals or the people who are applying for the loan, and they have filled it back and given it to the manager. Now, as per the norm of the bank, consider hypothetically it is United Bank of India or BOB, Bank of Baroda, or SBI, whatever you consider. It can be syndicated bank, the Punjab National Bank, and so on and so forth. Now, consider the overall score the bank manager have been told based on which the loan can be given is 60 out of 100. Now, let us draw a diagram in order to make a very good picture of what it means. So, if you see, there is, let me try to basically change the color, so it will give you a good picture. So, this is the first part which is green in color, this is the red part. Now, let me also highlight few other things. Consider this is the average of the first curve on the left, which is green. Let us consider the average of the second curve, which is on the right, which is left, the red one, and also let us consider the average point based on which the loan would be taken, which I mentioned few seconds back, is 60. Now, concentrate on, now I am not going to change the color, but just mark it in order to explain the example. So, please, I am sure my students would understand. So, they consider this is the first part graph and this is the second part. Now, if you look at the second graph, which is red in color, it means those set of people who are able to repay back the loan because their overall rating is higher, and consider this is 75. This is I am just taking arbitrary values. On the other hand, the green graph means basically means the set of people who, if given the loan, are not able to repay back. Consider their score is 55. So, this 55, this 60, this 75 are just arbitrary values for us to understand. Now, concentrate on these two hashed areas. So, I have basically done in opposite diagonal direction. So, if you notice this part, if it is possible, let me change the colors, because now it is relevant that we change the color. Yes. So, this portion which I marked, this I am using a much bolder tipped electronic pen. So, this mark which is dark in color, actually if you pay attention to that, it means the set of people who would have been able to repay back the loan, but they are denied the loan, because their score here, if you see, I do not want to mark it because the color would again come and it will become very messy. So, these scores are less than 60, even though their average score is 75, so they are denied the loan, which means this is an opportunity cost loss for the bank. Now, consider that with respect to the second portion, which is here. So, if possible, again let me try to highlight the color. This one is it's still highlighter, then I go here. So, this portion, consider this one, this, even I am sorry, the color differentiation is not happening, I apologize. So, if this portion which I marked, it means the set of people, or the probability that the person should have been denied the loan, but he is given the loan, which is a bad loss for the company. Now, with this example, if you consider and come back to this table which I had shown, which is technically used in the area of hypothesis testing, this alpha and beta can be made from this diagram also, where one area would be alpha and one area would be beta, which would technically mean that I am basically incurring type 1 and type 2 type of errors, such that any error reduction would basically give me a benefit. That means, if you go back to the first so called example which I have discussed in the sixth class, that is the first class of the second week, where the probability was given of completion or getting the material right on time was 90% and 10% that there was a delay, and then obviously there would be a cost of 2000 rupees, if you remember. So, if you try to basically understand that with respect to this example, it would mean that there would be an error for each and every decision process, alpha and beta. Trying to reduce alpha and beta would obviously be good for your own decision making process for the project. But there is a catch here. Considering this normal distribution which I have used and drawn here in this green one and the red one. Now, if you try to shift the line which is the vertical 60, you will see the overall area of alpha and beta are not reduced at the same time. So, if you reduce alpha, that means if you take 60 onto the left from my side, that means it is going more towards 55, that means one of the area which is there the left hand side will start decreasing, but on the other hand the other area would start increasing. So, trying to basically minimize both of them in concept of hypothesis testing is never possible. So, what we try to do is that we try to basically reduce the overall risk which is basically alpha and beta, and there are different techniques in statistics which you do that. Now, with that if you come back to this example or the table which is drawn on slide number 70 here, it means there is a low, medium and high consequence also. So, this is a very simple case of a discrete case where there are 3 outputs, and the example which I just drew was basically the concept of the continuous distribution of the normal case. Now, as you have this chart, what you will do, you will try to basically mark them with different probabilities, like what is the likelihood of the work being completed within 90 days, the example which I discussed in the last class, that means the 6th one. So, there is a time period, an average time period of 90. So, obviously, you can either exceed or you can basically be able to finish the work much before 90. So, if these probabilities are given and what are the consequences? Consequence obviously, we will try to understand from the point of view inclusion of budget being exceeded, the amount of materials being used much more, or whether there would be any technical difficulties, or whether you are trying to use different type of resources like man, machine, so on and so forth. So, all these consequences would be drawn on this table, considering that the overall project is in there in front of you. Obviously, you can break this table into more macro levels for each and every activity which will be comprising and making up the overall project. So, if you consider the risk factors, there would be loss of lead programmer, that these are the consequences, but obviously, there would be an effect on the quantitative sense, we will see that later on. So, there would be technical failures, there will be budget cuts, there will be competitors first in the market, and the consequence can be either high or low depending on what type of projects we are doing to, and likelihood and the impact potential would also be analyzed by the project manager team, the project supervisor and the organizational manager who has a vertical and a horizontal HR relationship with the project team as such. Because if you remember, I did mention time and again in the 5th class and also briefly in the 6th class that the overall the concept of the project management team as such is functioning in such a way that its overall objective is to meet the organization objective. So, these impact potential, likelihood potential and the consequences which you see here in both the matrix as well as the top table would be high and low depending on how you have been able to quantify the overall risk. So, if you want to basically be much more stringent, so obviously you will try to make more categories of high, very high, low, very low concept of risk, and the consequence would also be mapped correspondingly in order to understand the picture in a better light. So, once the probabilities are given, you will try to find out what are the effects which you have on a scale of say for example 0 to 1 or 0 to 100 or 0 to 10, whatever it is, and then try to find out the probabilities accordingly. Once the probabilities are found out, then again going back to the last example, we will try to find out what are the delay cost per day considering the linear or a non-linear cost, then try to multiply by the number of days considering it's either a independent structure of probability or dependent structure of probability, and try to find out the overall risk or the loss. Strategies when risk is there in the project. First task is accept risk is there, because risk is what is basically means there is some amount of variations, and if it is a non-deterministic process, obviously all decision making processes are non-deterministic, and in project management obviously you will have different type of stochastic or non-deterministic process or events. So, if there is risk, accept it, and if you accept it, you basically make your plans accordingly. So, if there is delay, you will basically consider that there is a delay and do it accordingly. Another way would be basically considering that risk is there, you cannot make it 0, try to minimize it. So, minimization can be trying to basically dovetail the work in such a way that two of them work can start consequently or subsequently, such that there is no misutilization of the resources, in the sense that the utilizations of the resources are done in such a way that one resource utilization in event 1 or work 1 or job 1 does not affect the utilization of resources for job 2 or event 2. Share the risk with other parties involved. So, if there is a risk for, say for example, from your side, so try to basically pass it on to the vendor. Obviously, there would be contracts for that, such that if there is a risk being borne by the vendor should also get some benefit. So, there you basically try to share the risk in such a way that overall job descriptions and job distribution, I am using the word job in a very layman sense, that the overall project work has been broken down in different components, such that the sub macro work is being done by different vendors or different departments, such that the overall risk is reduced. Transfer risk to other parties who may not be a part of the project. So, it can be, say for example, in finance we can even go by trying to buy different type of derivatives, different type of forwards and futures, such that the overall risk of the project is reduced. Consider this example. You have oil exploration coming up and you know that within 3 months you would be in a able position to tap the oil and sell the oil in the crude as a crude in the market. But consider that oil as of now arbitrarily considered is $130 per barrel. But you think that once the 3-month period is up, where you have already invested a huge amount of money, suddenly there is a chance that the oil prices may crash. So, what you will try to do is that try to find out different type of derivatives which are there in the market, forwards in the market, call options which are there, put options which are there, try to basically formulate your strategy of selling the oil in the market using different type of derivatives, such that you do not make a loss. In the sense, if the oil prices suddenly falls, you are not forced to sell the oil at the low price. But obviously, there would be a flip side also, in case the prices increases, you would definitely be in a position to sell the price at the higher prices. So, obviously, if you want to get the benefit on both the account, you have to make some additional cost in trying to buy different type of financial instrument to mitigate this overall negative impact. So, the word negative impact I am trying to utilize in the sense that any downward movement of the price is bad for you, or any upward movement of the price which you cannot utilize is also bad for you. So, you would always try to basically get the benefit on both the accounts. So, if you see the overall layout of the process, there would be decision factors and decision methods which will basically affect your decision preparation stage, and there would be inputs coming from different angles. It can be from the project management team, their vendors, it can be from the design team, it can be from the HR perspective, it can be, say for example, from the sales perspective, and based on all the design factors, the design methods, what are the decisions, what is the political environment, what is the inflation rate, what is the dollar to rupee rate, so on and so forth, basically sets into motion the decision, and that decision once basically thought in details goes into the action phase. And as the action phase goes, if you see that as the project is being implemented, obviously there would be different type of uncertainties. Say for example, I did not foresee, consider the company did not foresee there would be huge turmoil in, say for example, in one XYZ country where the project was being built. Consider the project was trying to build up a cement factory. Suddenly there is a huge political crisis in that XYZ country, whatever that country is, which would mean that there is a huge amount of uncertainty in the environment. If there is an uncertainty, it will affect your decision making process, and the overall result would definitely be affected negatively from the point of view of the project management. Or consider, say for example, you want to build up a harbor in the area of Andaman and Nicobar, or say for example, in the east coast of India, and suddenly a natural calamity comes. So, if that natural calamity affects your overall project of building the harbor, or say for example, the dockyard of the ship, then obviously it will have an effect negatively on the total project which you are planning. It may also happens, consider that suddenly the prices of the material based on which you are trying to build up the project. Consider very simply, you are trying to build up a very sophisticated transformer, and the copper prices suddenly rose astronomically or exponentially. So, obviously, it will have a negative impact. It may also happen that your main engineer who was doing the work suddenly shifts the company and moves to your rival company, that could also have a negative impact. So, all these things, uncertainties have to be taken into consideration, based on which the result, final result would basically affect the total project management decision process which is being undertaken by you and your team. So, the decision making process which I have is basically, or you would have, is basically a function. So, these f, x, t, y, z which I have inside that bracket are different variables. So, x can be cost, t can be time, y can be, say for example, inflation rate, z can be gold to rupee price, gold price, and so on and so forth. So, the non controllable factors or the potential states based on which they can happen, and here sorry, this t is basically the non controllable factors, not time, but generally you can take t as a time also. You have the controllable factors which are under your control. So, there is a white noise which is being affected, and you have some control on the white noise and some control you do not have on the white noise. So, you basically try to differentiate if you can break down in the effect into two different independent factors. The results and the consequence can be target variables, can be irrelevant variables. So, consider that you are distilling petroleum and the price of kerosene, which may be one of the byproducts, has crashed. So, if it has crashed, which means that you cannot sell the petroleum, it is basically a loss, and you have to basically term it as an irrelevant consequence or irrelevant variables based on which you will make your decision. On the other hand, consider the price of gel or petroleum gel due to some reason that suddenly some medical discovery was made and it was found out that petroleum gel had a huge amount of medical benefits for some medicine. If suddenly that increases, then it would basically have a huge impact on your project, even though your main consequence was basically not to manufacture petroleum gel. So, these positive and negative impacts would basically have at the end result also, such that you will basically decide your project management scope of things in the overall sphere, where both external and internal factors would be affected either positively or negatively to affect your overall project implementation phase till the result. There are three different decision problems depending on the results of the non controllable factors. The results are known with certainty, the probability distributions of the results are known, and the probability distributions of the results are unknown. So, if you consider the first effect, that the results are known, such problems are called decisions under certainty. So, if you have decisions under certainty, the concept of risk would not arise, which means that all things are known to you, you know the time, you know the resource constraints which are there, you know the cost implications, there is no change in the cost implications, all the variables which are external and internal to the system are known to you with certainty value or 100% probability value, and you work accordingly. In the second thing, if there is certainty, is if the concept is not there, you will basically consider them to be non-deterministic or stochastic. Now, if it is non-deterministic and stochastic, then 2 points would come under point number 2, under the second bullet point. Number 1 is that the probability distributions are known and they are independent. So, if they are independent, if you remember the first example, it will be very simple calculation of the expected value if you want to find out the overall average value for each and every event. Add them up, find out the probabilities, find out the overall variance, and do your calculations accordingly. Now, this adding up of the probabilities, if they are independent, would be true for any type of distribution. But consider that if the distributions are dependent, if they are dependent and if they are normal, then trying to basically find out different type of normal distribution considering different combinations of normal distribution is simple, because normal distribution has very fantastic properties, which I do not want to mention because this is not part of the course. People who are interested can check up the properties of normal distribution. But if you consider the distributions are non-normal, then it will mean that if they are non-normal, then they, and if they are dependent, then obviously it would imply that the concept of correlation would come into the picture, the concept of covariance would come into the picture, the concept of joint multivariate distributions would come into the picture. And if you consider the concept of extreme value distribution, just I am mentioning that for the interest of the readers, that extreme value distribution considers that the overall risk are at the extremes. So, if you consider, just for the interest of the readers, I am just giving a very brief review. It has no mathematics as such in the discussions. So, if we know the normal distribution, let me continue using this pen, which is a little bit bold. So, consider this is the normal distribution, and in the extreme value distribution, your distributions would be like this, where the overall effect would be on the extremes. So, if you are trying to basically combine the extremes, then trying to find out the overall effect on combination of different type of extremes would mean that you cannot use covariance structure as such and try to utilize the concept of, say for example, copular theory in order to combine the different distributions. The probability distributions, if they are unknown, then trying to utilize different type of Bayesian concepts. Bayesian concept means basically you try to analyze the problems that considering prior distributions of the different parameters are known to you with some certainty value or means certain uncertainty value. And then you try to combine those prior information in trying to basically predict what would be the parameters. Parameters means the general variables based on which the distribution is been built. So, if you consider the normal distribution generally has mu and sigma. So, these are two other parameters for the normal distribution. So, the probability distributions, if they are generally not known, then you consider the concept of Bayesian concept, utilize the Bayesian concept to find out the distribution, and then combine the concept of Bayesian distribution along with dependent structure, independent structure, and then do your calculations accordingly to find out the overall probability. A commonly applied technique for solving project management is basically the expected value concept. We will come to that later on. We have been mentioning about mean value, it has something to do with the concept of mean value. The expected value concept assumes that we know the potential result of the probability with some associate probability. So, if the associate probability is known, we have the expected value, we also have the variance, because both expected value, which is the first moment, and variance, which is the second moment, would give us a lot of information and implication of how the project is going. Hence, by multiplying each potential result by its probability, if you remember the last example where the amount of rupees lost, that is 2000 rupees multiplied by the number of days multiplied by the probability, if you remember that calculation, it would exactly mean what the third point means. Hence, by multiplying each potential result by its probability and aggregating, we obtain the expected value of the total project, considering dependence and independent structure being there, not there. So, obviously, the calculations will change. This is the average value technique we would utilize, and through that we will obtain if you were able to execute the project a large number of times. So, this concept of large number would basically have an implication how we do the concept of simulation in trying to find out that what is the average time a project would be finished. I will come to that later on. The value is not necessarily the value of one specific results, it is just a reference that for taking the best decision and trying to implement it time and again, like till an infinite level of simulation, you will try to basically get the average value as the best probable date by which the overall project would be finished. So, with that I will finish the 7th lecture, which is the second lecture for the second week, and start with the third lecture for the second week in the next class. Thank you very much.